Hello all, welcome to the last section in Module 5, Section 2.4. We will be looking at some more on slope, which is going to include average rate of change and also parallel and perpendicular lines. So let's look at some notes real quick. Those are the ones from last lecture, so let's go ahead and move on down. So two quick things. So parallel and perpendicular slope. So this is the first thing. So, I mean, you really want to think about the picture. For parallel, it's pretty obvious. If we have two lines, say in the xy plane, that are parallel, that means they never intersect, just move right along next to one another. What's going to happen here? Well, remember, slope measures steepness, so these two lines have equal slope. So if you had two equations of lines, say y equals, we'll just call them two different things. y1 equals m1 x1 plus b. Actually, we don't need the subscripts for the y and the x, just for the m. So we'll just say y equals m1x plus b. We'll call this line 1 and this line 2. And y equals m2. X plus b is the equation of L2. Then we know that m1 equals m2. Normally, normally when you have a question, it'll be something like you have a line with equation, say 2x plus 5, y equals 2x plus 5. Find the equation of the line that is parallel passing through another point. And then the information you basically get for free is that your other line has to have slope 2 because it's parallel. Okay, so that's the parallel case. So maybe I should write that up here. That was parallel. The other one is perpendicular. And what perpendicular means is that your two lines are going to meet at a right angle. So say this is L1, and then L2 is perpendicular. So what that means is this forms a 90-degree angle. Then if you have, so they have opposite reciprocal slopes. So what that means is if you had the same setup as before, so let me give myself just a little more space. If you had the two lines, L1 being given by y equals m1 x plus b, and L2 being given by y equals m2 x plus b, then we know that m1 has to equal negative 1 over m2. So the way this might work is if a line, for example, has equation, say y equals 3/4 x plus 2, then we know what the slope of any perpendicular line must have. Then the slope of a perpendicular line must be, so what you do is you flip over the fraction, or if it's a regular number, you still flip it over, and then change the sign. So it must have slope, or must be, we'll say m equals negative 4 over 3. And that's all you really need to know for parallel and perpendicular lines. So let's do the first two exercises in the learning guide, and then we'll come back to the notes and talk briefly about average rate of change before we finish up the material. Sorry, I got some really good coffee. It's always a treat. Okay, so practice problem number 1. Write an equation of the line passing through -8, -10, and parallel to the line whose equation is y equals -4x plus 3. Okay, so they want us to write the equation first in point slope and then in slope intercept. So we know our equation has to have slope -4 because it's parallel to the other line and passes through -8, -10. So now we have all the information we had in the last section, so we can use it the same way, but I will remind you of the point slope formula. So it looks like this, where x0, y0 is the point. So when I say x0, y0 is the point, and m is the slope. So we just plug that in, y equals -4. And then since x0 is -8, when you subtract it inside these parentheses, it becomes +8. And then since y0 is added, since it's -10, it becomes -10. Okay, and then don't forget about the second part, slope intercept, that basically is code for solve for y. So this is, again, the point slope. And to do the slope intercept, we do y equals -4x minus 32 minus 10. We have to distribute. And then we combine the like terms, y equals -4x minus 42. And this is called the slope intercept, the y equals mx plus b form. Alrighty. The second one, write an equation of the line passing through 4, -7 and perpendicular to the line whose equation is x minus 2y minus 3 equals 0. And then again, they want to express the equation in the standard ways. So they actually say general form, which is another form of the line we haven't talked about, but it's not important at all. So I'm just going to do the second one. Let's change this to slope intercept, because those are the questions I'm going to be asking you. If you're curious, standard form looks something like or general form looks something like ax plus by equals c, but it's not interesting. The only thing you can quickly identify are the intercepts, but it's not even that great at that. So let's just keep it simple and go with point slope and slope intercept. Okay, so the first thing is we have to figure out the slope of this guy and then take the opposite sign and flip it, because we want the perpendicular line. So first let's solve for y. So let me write down the x minus 2y minus 3 equals 0. So kind of step one, let's find the slope. So first thing, solve for y. So I'm going to move the 2y to the other side so it changes signs. And then I divide by 2. Same trick as last time. And then we have a big fraction on the left, so we need to split that up into two fractions with our common denominator. Okay, so what is the slope of our line? The x over 2 is going to tell us, so the slope of this line is 1 over 2, so the slope of our line is -2 over 1, or just -2. So now we can find the general equation. We just have to remember our point is 4, -7, so needs to pass through. For -7. So step 2, we need to find the equation. So here we're going to do y equals -2 times x minus 4 minus 7. That's our point slope equation. If you're curious how we got that, just remember the formula to get these. So this, I'm just going to write point slope, and then over here we're going to put this in slope intercept by multiplying out the -2. So 8 and -7 can go together, so that makes -2x plus 1. And this is slope intercept. Alright, Let's look at the next one. So that's it for parallel and perpendicular. Same steps as last time, you just need to identify the slope first, given whether you have a parallel line or perpendicular line. Okay, pencil problem number 2. In 1994, 617 active duty service members were discharged under the Don't Ask, Don't Tell policy. In 1998, 1163 were discharged under the same policy. Use the ordered pairs to find the slope of the line through the points. Express the slope correct to the nearest whole number and describe what it represents. Okay, so this is nothing new, but it's an interpretation of slope. So, just a real quick heads up. What are the units of slope? Well, since slope is change in y over change in x, the units of slope are units of y over units of x, or units of y per units of x. For instance, if we had 2 displacements and the second, so we had 2 distances traveled over some amount of time, what would the units of the slope be? Say it were miles and hours, then it would be velocity, miles per hours. So it's a very natural notion. So let's do the slope formula real quick. So m is going to equal 1163 minus 617 over 1998 minus 1994. So we know on the bottom we just have 4. And on top, let's see, I'm trying to do mental math again, so stick with me. I think it's 546. Right, so if you would add 617, you'd get 1100. Add 10, you'd get 1156, and add 7, you'd get 1163. So yeah, that's right. And then does this go in? I think so. So 4 goes into 5 once. Carry the 2. 4 has to go. So we've got 1 left over. So 4 goes into 14 3 times, with 2 left over, and then 26. So it's not going to go in quite. I think we're going to get a 0.5. Right, so 4 goes into 5 once, carry 1, 4 goes into 14 3 times, carry a 2, 4 goes into 26 6 times with 2 left over, and 2 over 4 is 0.5. So that should be 136.5. Let's double check it on the calculator so I don't make a mistake like I did last video. I always prefer doing mental math to keep me sharp. Okay, 136.5, we did it. Okay, so let's ask what are the units. Well, the y value units are the number of people discharged, and the x value units are years. So it should be number discharged per year. So what this is telling us is the average rate that's changing. So between 1994 and 1998, there was an increase of 136.5 service members discharged per year. Okay, so now we're going to get into average rate of change, and that was really kind of an average rate of change problem. So let's go back to the notes section, and this is pretty much the last topic. So average rate of change, don't be scared. I know it sounds so frightening, but average rate of change. A lot of times I represent with ARC, just like that, capital ARC. So let's look at the picture. So the idea is you have some function that's not a line, but you'd like to model it or see how it behaves linearly. Maybe in some small neighborhood it actually behaves like a line. So say we have two values x1, x2, and this function is named f. Well, between these 2 points on the graph, it behaves kind of like a line. So, we'd like to say, what is the equation of that line? Well, right now we only have the x values, but since we know the function, anytime we know a function, we can plug the x values into the function to get the y values. So, what is the first point? Well, that would be x1, f of x1. And the second point would be x2, f of x2. So the average rate of change is just the slope formula between those 2 points. But there's one extra step because first we have to get the y values. And remember, if we interpret these, we still interpret as units of y per units of x. So it works exactly like the slope formula. So let's go back to the learning guide and do a couple of these. So it says find the average rate of change of the function from x1 to x2. So our function is take the input and triple it. F of x equals 3x, and we have 2 x values. So the first thing is get the 2 ordered pairs. So when you do f of 0, we get 3 times 0, which equals 0. And when you do f of 5, we get 3 times 5, which equals 15. So we get our 2 ordered pairs, 0, 0, and 5, 15. So now, to find the average rate of change, we just do the slope formula between those 2 points. 15 minus 0 over 5 minus 0, which is 15 over 5, which equals 3. Let's do the next one. So we have 2 ordered pairs. We have a function x squared plus 2x and 2 points, 2 x values. So we need to find first the 2 y values. So f of 3 is 3 squared plus 2 times 3, which is equal to 9 plus 6, 15. So this gives us the point 3, 15. And then f of 5, which gives us 5 squared plus 2 times 5. So in this case we get 25 plus 10, which is 35. So 5, 35. So again, the average rate of change, we just do the slope formula. 35 minus 15 over 5 minus 3. 20 over 2, which in this case equals 10. So, last one, f of x equals the square root of x from 4 to 9. Well, this one's actually pretty simple, so I'm just going to say them because we don't even really need to plug them in. Take the square root of 4, you get 2. And take the square root of 9 and you get 3. So, the slope, the average rate of change, is 3 minus 2 over 9 minus 4, which is 1 over 5. So what we're doing is we're just approximating these functions with their linear slope between them. And that is it. Alright, so we're basically done, but I do want to go back and show you one more thing because why? Well, I told you way back in 2.3 or 2, there's one we didn't do called the difference quotient. I'm not really going to ask you any of this kind, but I'm going to explain to you what it is. So let's go back to the notes. It's really average rate of change. That's why I wanted to wait. So what did we do for average rate of change? So this is the difference quotient, which is really just another sneaky way of thinking about slope. So if you want to approximate the point, say, so again we have some function, and let's make the picture big just to see. Well, we'll call this point. What we were doing for average rate of change is we were giving them 2 different names, x1 and x2. But let's call the first point x, and again that represents the distance from 0. And then if we call the distance here h, we can think about this point as being x plus h. Okay? And then this point will have y value f of x. So this will be the point x comma f of x. And this point up here will be x plus h as the x value, and then f of x plus h is the y value here. And then what the difference quotient is it's just the average rate of change formula between the 2 points. F of x plus h minus f of x over x plus h minus x. Well, the way we've written it now, the x's on the bottom cancel, so the difference quotient can actually be simplified a little bit. F of x plus h minus f of x over h. And then, as it turns out, when you try to simplify a difference quotient, what you really want to do is you want to try to cancel the h in the denominator, and then you'll get a function that represents the behavior of the change of the function over the entire interval, over any single point. Really, this is what the derivative is in calculus, which is why I think it's a little of an advanced topic, but we'll do one example so you see what I mean, and you won't have to really worry about it on your tests. So how do we find and simplify the difference quotient? Well, let's think about the 2 points we're trying to find the average rate of change between. We know when you plug in x, you just get the slope, you get for the y value x squared minus 4x plus 3. Right? Whenever you have function notation, whatever's in parentheses is what you plug in, and the formula gives you the way to find y. Well, what happens if you would plug in x plus h? Well, remember what you would do is you would just do x plus h in parentheses wherever you would normally see x. Okay, so now the difference quotient is just going to be the slope formula between these 2 points. So we'll have x plus h squared minus 4 times x plus h plus 3 minus, minus x squared minus 4x plus 3. Notice I kept parentheses when I subtracted this bit because it's got more than one term. So when you subtract the whole thing, you're going to need to distribute that negative. And then on the bottom, we just do x plus h minus x, but as before, this is always just going to be h on the bottom because those x's cancel. So now on top, what we want to do is multiply everything out. Some of this you might be a little rusty on, but remember first x plus h squared is x plus h times x plus h. So if you forget how to do that, go ahead and write it out, x plus h times x plus h, and FOIL it. On top here, simplifying, I'm just going to write what it actually is. So x squared plus 2xh plus h squared, and then the next bit, minus 4 times x plus h in parentheses, we want to distribute, minus 4x minus 4h plus 3. And then the last bit, to get rid of the parentheses, we want to distribute that negative. So we get minus x squared plus 4x minus 3. And then on the bottom, we just have h. So now we just look for things to cancel. There's always going to be a lot of cancellation in this step. So the x squareds, those go away. The 4x's, those cancel. The 3's, those also cancel. And what is left over? Well, we have a 2xh, and h squared, and a minus 4h. Well, there's one more cool thing we can do. Everything on top has an h, so we can factor it out. So we get 2x plus h minus 4, and we still have an h on the bottom. So we cancel those things out, and we finally have the simplified version of our difference quotient, 2x plus h minus 4. And that would be the simplified difference quotient for this problem. I don't like the way they do it in this section because they didn't explain to you that it came from average rate of change. So that's why I wanted to hold off and show this one until we'd seen average rate of change. Again, this is a pretty difficult one, I know, but I won't be testing this. I'll just be testing the normal average rate of change. But now at least you've got some exposure to calculus, and you can see like the really interesting technical aspects of it. So the difference quotient is actually very useful, and what it determines in general is the behavior of the change of a function. So it gives a formula for that, what is going to be end up calling the instantaneous rate of change. But right now we're just kind of looking at the average rate of change. Anyway, I hope you enjoyed the lecture, and good luck on the rest of the homework and the test.